Okay, so the topic for today is going to be inverse trig functions, and I decided to split this section into 2 days because I think there's a lot of information here. So we're gonna get started today, finish tomorrow. You already know a lot about trig functions and their graphs. Um, Now we're going to look at the inverse of the trig functions. This first part here, I just posted more for you to see where the domain and the range restrictions come from. So you can read on your own, but pretty much what they're doing is taking an interval before the function repeats itself and just isolating that interval. As you know, for the prerequisite to have a function is that you cannot have more than one y value for each x value. So you have to restrict the domain here. That's why I'm showing you this. I just want you to know where the domain and range restrictions come from. So if you take into consideration the whole function, then this is going to go like this, which in this case would give you more than one y value for each x. So you have to restrict the domain. Okay, so I don't want to spend too much time on that, but you should know that the inverse function for sine, cosine, and tangent are called arcsine, arccosine, arctangent, and this is really what I'm interested in. That the domain, if you're looking at the inverse function, the domain for arcsine or inverse sine or sine -1 is going to be between -1 and 1 including, and the range is going to be negative pi over 2 to pi over 2 including. Okay, so this is a visual of what the range restrictions are. Negative pi over 2, pi over 2 might be helpful for you to see that. But let's get to the actual exercises and see how you'd apply that. So this is something you should already know. In the past, I have asked students to memorize this. I've given quizzes, but now because of our remote instruction, there's really no way for me to check whether you're having access to resources to give you this information or not. So I'm not really quizzing you, but you should know this for the future, especially if you're planning on going to calc. You must memorize this. And the way I always draw my own little chart when I have to use this. And the only one that I really memorize is sine 30 is 1/2. Now, because 30 and 60 are complementary angles, then I also know that cosine, sine, and cosine of complementary angles will be the same. So if sine 30 is 1/2, cosine 60 is 1/2. And then I just remember special right triangles, and I know that if it's a 30, 60, 90, the long leg is square root of 3. So I fill out the other stuff. And then the cosine 30 and sine 60, radical 3 over 2. And I take it from there. For 45, I know that the sides are the same, and I sort of remember it's going to be square root of 2 over 2. And then for sine and cosine of 0 and 90, I just remember the x and y coordinates. But in any case, this is something you need to know to be able to answer the questions that are coming up. So let's take a look at 1a. 1a is asking you to determine what arcsine of radical 3 over 2 is. So now if they are asking for arcsine, essentially what they are asking is, what is the angle? What is the angle that will have the value of sine that is radical 3 over 2? And then you have to look at the domain restrictions. So then radical 3 over 2 for sine is over here. Actually, let me just erase this. we don't need this, and we don't need this. All right, so let's look over here. I'm looking for radical 3 over 2. Radical 3 over 2 for sine is over here, right? So the angle is 60 degrees, or pi over 3. So then the question is, does that satisfy my domain and range restrictions? And the answer is yes, because for sine, the domain has to be between pi over 2 and negative pi over 2. I can go back and show you that. Okay. All right. So it says here that the domain, sorry, the range is negative pi over 2 and pi over 2. So pi over 3 is in the domain because it's between negative 1 and 1, so it does exist. So because pi over 3 is here, then we are good. It exists. And now my answer is going to have to be between negative pi over 2 and pi over 2. So the angle that has that value for sine is pi over 3, and pi over 3 is between negative pi over 2 and pi over 2. So I can write my answer here simply as pi over 3, and I'm done. Okay? Now, for the next question, 1b, it's asking you, which angle has a sine value of negative 2 pi? Well, the problem is that negative 2 pi is not between negative 1 and 1. So because it's not between negative 1 and 1, it means it does not exist. So as you can see here, here we go. So because it's not between negative 1 and 1, then it does not exist. So you have to constantly be checking the domain and range restrictions. Okay, so this one does not exist, or DNA. Exist, I think there's an H, right? Exist. Yeah, sorry, my spelling is going bad. Exist. So I'm gonna abbreviate and just put the DNE, which is actually what you're gonna see more often. DNA. DNE does not exist. Now the third one is, which angle has a sine value of negative 1? So I know that a sine value of 1 is 90, which is pi over 2. However, I want it to be negative, and I know that the interval has to be between negative pi over 2 and pi over 2. So it's just going to be negative pi over 2. So this is negative pi over 2. And I am done. So once again, you're just pretty much going backwards, and then you have to check the domain and range restrictions. That's for sine. Okay? Now we can take a look at cosine. So for cosine, same principle. But the only thing now is that if you look at the range is going to be the same, but the domain, here we go. The domain restriction is going to have to be between 0 and pi, so it's first and second quadrants. Okay, so now for sine, it's pi over 2, negative pi over 2, or negative pi over 2, pi over 2. Now it's going to be 0 to pi. So you can see your little circle there. Before you had first and fourth quadrants, now you have first and second quadrants. Okay. All right. So I attach the table here again, although, like I said before, you should memorize this. So now they are asking which angle has a cosine value that is negative radical 3 over 2. So I have that here. So this is radical 3 over 2. But now I have to have this negative value, and it has to be first and second quadrants, right? So pi over 3 would be would have a cosine value of radical 3 over 2. Remember, cosine is the x value, so it needs to be in the second quadrant. So you can think of it as pi minus the reference angle, which is pi over 3. So you think of it as pi minus pi over 3, because you need to have cosine. Oh, yeah, radical 3 over 2, you want it to be negative. Okay, so yes, this is pi over 3. Oh, I'm looking at sine. Never mind. That's why it's not making any sense. Cosine. Sorry, guys. Cosine. Not sine. Cosine. All right, so cosine radical 3 over 2 is here, which is pi over 6, right? Okay. Now I need to find the one in the second quadrant, because remember that the range is going to have to be between 0 and pi. So now I need to do my pi minus pi over 6, because it's negative. So then I get 6 pi over 6 minus pi over 6, and the answer is 5 pi over 6. Okay. Now for arc cosine 2.5, we have a problem, because the domain is not between -1 and 1, so this one does not exist. And then for 2c, they are saying which angle has a value for sine that is -1/2, and remember, the domain has to be between -1 and 1 for inverse cosine functions, and the range is going to be 0 to pi. So now we need to take a look at 1/2, and we're looking at cosine. So I can see it over here. I know that cosine 60 is 1/2. So here you are. 60 is pi over 3. So this is for pi over 3. But now I want a negative. And remember, cosine, for inverse cosine, the angle has to be in first and second quadrants. So now I have to do pi minus pi over 3, which is going to give me 2 pi over 3. Okay? All right. Moving on. This is the third and last portion for today. So now they're doing to find the inverse tangent function or arctangent. You have to restrict the domain to -pi over 2, pi over 2. you have to restrict the domain of the tangent function. So here is the summary we need. So I was looking for, there you go. That's what I was looking for. So the domain of the inverse tangent function is negative infinity to positive infinity. So no domain restrictions, but then the range is going to be to positive pi over 2 and negative pi over 2. So that's down here. There is a very nice summary later. I'll show you that to help you with the restrictions. Not including pi over 2 and negative pi over 2, of course, because you get a 0 in the denominator, and which means then they're not included. All right. So now, arctangent negative radical 3 over 3. So here we are. And it has to be first and third quadrants. So this would be 30, which is pi over 6. But we want the negative, so negative pi over 6. Okay. And then for tangent negative 1, we have that tangent 45 is 1, which of course you already know. Now for negative 1, to get negative 1 in the interval negative pi over 2 and positive pi over 2, it would have to be negative pi over 4. Okay. So is that summary here? It's not here, but it will be in the next section, the summary for domain and range of inverse functions. Okay. If you want, I can always, I can just quickly write it here for you. So, okay. So this is what you need to do for arc sine or inverse sine. The domain is going to be between negative 1 and 1, including the range has to be between negative pi over 2 and pi over 2. Including. For arc cosine or inverse sine, cosine, the domain is between negative 1 and 1, and the range has to be between 0 and pi. And arctan or inverse tangent, domain is negative infinity to positive infinity, and the range has to be negative pi over 2 and pi over 2, but those cannot be included because they're undefined at those points. Okay, so I hope this helps. Tomorrow we're going to talk about composition of functions. Okay, have a great day. Thank you.